Singularity-embedded topology. The architecture of a living planet. Most scientific revolutions do not begin with equations, they begin with an uneasy discomfort, a persistent sense that something fundamental is missing from our picture of the world. In the case of Earth sciences, that discomfort is unmistakable. Our planet behaves like a deeply coordinated system, yet we persist in modeling it as a collection of loosely coupled parts. The mantle convects, tectonic plates drift, the magnetic field reverses, climates oscillate, life adapts, and consciousness eventually emerges. These processes are treated as neighbors sharing the same address, but rarely as members of the same family. What if they are family? What if Earth is not merely a thermodynamic machine shedding primordial heat into space, but a structured, memory-bearing system guided by internal organizing principles? This is the heretical proposition at the heart of singularity-embedded topology, set theory. SET does not reject the triumphs of modern geophysics, it asks whether something foundational has been overlooked. A deeper topology beneath the crust capable of storing information, synchronizing disparate processes, and driving the planet through occasional bursts of rapid reorganization rather than endless gradual drift. Standard models explain motion and energy flow admirably, yet they struggle to account for the striking coherence and timing we observe. Geomagnetic excursions aligning with pulses of mass extinction, tectonic upheavals coinciding with abrupt climate shifts, and explosive biological radiations following planetary resets. At the core of SET lies a bold hypothesis: stable, ultra-dense space-time defects, singularity-like nodes embedded within the planetary interior. These are not the ravenous black holes of popular imagination, but topological anchors inherited from cosmic formation or forged during accretion. They serve three critical functions. First, they regulate energy, acting as sinks, lenses, or phase gates for heat moving through the mantle. Second, they store information, retaining structural memory of past planetary states that subtly bias future configurations. Third, they synchronize phases, coordinating transitions between quasi-stable modes of planetary behavior. This vision transforms the Earth's interior from a smooth thermodynamic gradient into a networked architecture. Volcanism, plate tectonics, and geomagnetic dynamics cease to be independent phenomena. They become surface expressions of deeper topological constraints. Nature frequently employs compact nodes to orchestrate vast systems. Neurons in brains, hubs in power grids, galactic centers, and SET suggests the planet follows the same efficient pattern. One of SET's most provocative claims is temporal. Planetary evolution is punctuated rather than smooth. Mainstream geology acknowledges catastrophes, yet treats them as exceptions to a gradualist rule. SET inverts this perspective, proposing that Earth spends long epochs in quasi-stable phases, interrupted by brief, intense reorganization events when internal thresholds are crossed. These events manifest simultaneously across domains: rapid magnetic excursions or full reversals, sudden climate bifurcations, accelerated tectonic rearrangement, and mass extinctions followed swiftly by evolutionary innovation. The Lachant excursion, for instance, is recast not as an isolated magnetic anomaly, but as evidence of a partial system reset, during which internal nodes temporarily desynchronize, permitting surface subsystems to explore new configurations before locking into a fresh, stable phase. Crucially, SET predicts clustering, multiple domains shifting within the same narrow geological window. Such synchronized coincidences, often dismissed with ad hoc explanations in conventional models, become expected consequences of an underlying coordinating topology. Memory, traditionally reserved for biological brains, is reclaimed by SET as a broader physical property. At its essence, memory as signia is any persistent structure that constrains future behavior. Crystals remember deformation, fault lines remember stress, magnetic domains remember orientation. Planets, SET argues, are no exception. The proposed singularity nodes function as long-term archives, encoding prior configurations. When instability approaches, the system does not evolve randomly. It references its historical library. This perspective reframes biological evolution itself. Life does not adapt in isolation, it rides and influences planetary phase states. Convergent evolution on geological timescales, recurring climate modes beyond simple orbital forcing. Even ancient cultural myths of cyclic destruction and rebirth may all bear the fingerprints of planetary memory. Resonance lies at the center of Set's dynamics. Every subsystem, mantle convection cells, ocean gyres, atmospheric oscillations, biological rhythms, operates within characteristic frequency bands. Under ordinary conditions, these drift independently, but during critical periods they can phase lock, amplifying small perturbations into massive outcomes. The singularity nodes act as frequency governors, facilitating alignment and coherence. This explains why geomagnetic instability, climatic volatility, and biospheric stress so often synchronize without an obvious unifying trigger. Earth behaves less like a blind machine and more like an orchestra capable of both discord and sudden breathtaking harmony. If the theory is correct, the crust itself is not randomly fractured but geometrically mapped, with plate boundaries, volcanic arcs, and seismic hotspots tracing the surface projection of deeper node networks. Resource deposits, gold, hydrocarbons, rare earths, should cluster along persistent energy pathways shaped by this hidden topology. Fluids follow gradients, gradients follow structure, and structure follows the deepest constraints. Life, far from being a passive passenger, emerges in Set as an active participant entangled with geophysics. Photosynthesis reshapes atmospheric chemistry, organisms modulate albedo, microbes drive mineralization. During planetary transitions, biology serves as both sensor and stabilizer, rapidly sampling configurational space while preventing total chaos. Extinction events become rebalancing acts within a larger dialogue between biosphere and geosphere, harsh yet far less random than conventionally portrayed. On the delicate question of consciousness, Set proceeds cautiously. It makes no claim that Earth itself is sentient. Instead, it observes that consciousness may arise more readily in systems already optimized for distributed information flow, coherent resonance, and long-term memory. Human cognition represents a localized, high-frequency echo of much slower, deeper planetary patterns, a recursive emergence that is poetic rather than mystical. Set earns its scientific legitimacy by offering falsifiable predictions. Temporal clustering of transitions across geological, magnetic, and biological records, persistent correlations between deep mantle anomalies and surface resource distribution, recurrent frequency signatures across nominally independent subsystems, and non-random timing of magnetic excursions relative to climatic instability. Should high-resolution data reveal only smooth, uncorrelated change, the theory fails honorably, and in failing, sharpens the questions we ask next. Ultimately, Set invites us to feel the planet differently, not as dead rock adorned with a thin living film, but as a profoundly structured, historical system that has learned over billions of years how to survive its own turbulence. Not alive in the animal sense, yet unmistakably alive in its capacity to remember, resonate, and periodically renew itself. Whether the theory proves partially correct or entirely misguided, it deepens the mystery, and that is welcome news. Mysteries remind us that we remain early in the story, and the universe tends to conceal its most elegant ideas in the opening chapters.